Darktrace has a range of deployment options in order to perform asset discovery. We have 9 different capture techniques in order to get data. The first 5 leverage passive port mirroring and deep packet inspection. Firstly, a range of physical appliances built by our own hardware team. Secondly, ruggedized industrial mini probes. Additionally, we have virtual sensors and OS sensors. And we can also host Darktrace infrastructure in public cloud environments. Additionally, we can further extend visibility with C-sensors, Darktrace's proprietary approach that allows more granular output than ever before, and marketed as Darktrace for Endpoint. We can also use active queries using native industrial protocols to further enrich asset information. We can also enrich from other tools in the ecosystem, such as CMDBs and directories using integrations. And finally, it is possible to enumerate CPS assets hosted in the public cloud, such as AWS, using a module marketed as Darktrace for Cloud. Regardless of which discovery methods are used, all leverage Darktrace's self-learning AI to learn normal without prior configuration on what normal means to that organization. The power of self-learning AI for asset discovery is that Darktrace can continuously map and monitor assets in real time without requiring manual configuration or ongoing maintenance. This is the homepage of the Threat Visualizer. The world map reveals 6 sites in 6 different countries, unified into a single view, but with each asset mapped to its latitude and longitude. It's worth noting that the CPS of each water treatment is very likely to be different from one another, and in fact completely unique. Yet Darktrace's self-learning AI performs across heterogeneous operational environments and architectures to make normal for each site and unify that knowledge into a single security platform. On the left-hand side, we can see a quick overview of what Darktrace has discovered. It has identified 1,348 patterns of life across 12 subnets and 53 IP addresses. Patterns of life refers to the unique connections events which have contributed to Darktrace's overall understanding of normal in the last 12 weeks. Below, we can visualize total bandwidth which has been processed by Darktrace over time. And above, we have a dashboard which maps security events to MITRE ATT&CK framework. This is the first of 2 dashboards aligned to the MITRE ATT&CK framework, but I will return to this later. Coming to the top of the Threat Visualizer, we have the OmniSearch function, which allows us to search for any asset IP address. I've selected one of the firm's CPS assets, which has brought it into the center of the Threat Visualizer. This is a real-time visualization of linkages and data flows to and from the asset. Using the playback feature in the top right, I can move back through time and replay incidents, alongside visualizing key statistics relating to the data flow. From the OmniSearch toolbar at the top, I can open the device summary. The device summary window reveals everything Darktrace has discovered about the asset: the asset name, the device category type, the vendor, the product family, model, and serial number. Other attributes include IP address, MAC address, subnet, the operating system firmware or software versions, and where SNMP is enabled, we'd find the asset location, including wireless access locations. Further down, we have tags. These are customizable and can be added automatically or manually, and can include things like network location or VLAN IDs. Darktrace uses connection info to track when each asset was first seen, and last modified, such as the IP history. It is possible to further enrich asset information using an integration with Active Directory. This means that when a user credential is associated with an asset, we can see further user attributes such as their job title, department, email address, or phone extension. There is also a free typing notes field where users may wish to add additional asset contributions such as USB devices and status on physical process-centric variables. On the right, we have a list of similar devices. This is a nod to Darktrace's AI in the way that it clusters devices into peer groups. It's not just comparing the asset to its historical self or to the network as a whole, but also to similar devices. It does this not by comparing its IP address, hostname, or location on the network, but by comparing its behavioral profile based upon Darktrace's understanding of normal. Further down, we have a summary of model alerts and AI analyst investigations, as well as graphics for devices used, in this case, a utilities workstation, and also the ports used. This gives us all open ports with a high degree of integrity and accuracy within just a couple of clicks. We can also determine the asset patch level using the ICS vulnerability tracker. We can view vulnerabilities for the device, and from there, pivot to the vulnerabilities for all devices on the network. We can list this by device or by CVE, such that we can identify all assets that are associated with a particular CVE. This is a correlation of asset discovery with CVEs and third-party vulnerability databases. A planned release for October 2024 will also extend this capability to end-of-life support status based on manufacturer databases. The result is that customers are presented with a user-friendly summary of each asset containing all the attributes Darktrace knows about the asset in one place, along with the ability to visualize its communication patterns in real time. In this example, the asset is associated with slots for additional units. Darktrace has been able to detect from the network traffic and create separate assets with the appropriate chassis and backplane numbers. Again, we can visualize these assets and bring up the device summary to learn the asset pedigrees and attributes Darktrace is associated with the device. If you wanted to view the asset inventory as a whole, rather than looking at them by one, we can bring up the device admin page using the summary panel on the left-hand side. This is Darktrace's asset inventory, and it dynamically updates all assets Darktrace tracks on the network. Darktrace identifies a wide range of OEM hardware and does not rely on partnerships with the manufacturers to stay up to date. Instead, Darktrace is able to automatically infer the make and models of CPS assets based upon the raw network traffic. The list is fully exportable via CSV, and also we can apply bulk manual tags. So for example, here we may wish to add the Siemens tag to all of these assets. The final feature I want to show as part of this use case is the Explore feature, which can be accessed through the main menu on the left-hand side. Explore provides a visualization of linkages and data flows between assets and sites. Asset groups can be dragged and dropped and repositioned such that you could create a Purdue model map, VLAN maps, zone cluster maps, external communication data flows, assets, and group maps, all of which can then be drilled down using the drill down capabilities for deeper investigation. This means we can find out which assets were the source of data flows. Unlike approaches which rely on predefined or static visualization, Darktrace adapts as assets are remapped or repositioned. So here we can see specifically on the right-hand side the event logs which cause the communication between these two areas, between WinDC and Workstation 2. Many solutions limit users to passive fixed mapping views, lacking real-time interactivity and drill-down functionality, which makes troubleshooting and flow analysis less comprehensive and more time-consuming. Explore's real-time drill-down into communication flows makes Darktrace ideal for detecting emerging threats and isolating abnormal traffic patterns. Competing tools that rely on more manual configurations or fixed assets require greater administrative overhead and bring out this real-time adaptability. To summarize this use case of discovering and mapping CPS assets, I have shown how our water treatment firm has been able to discover all their CPS and IT assets across 6 different sites. They can interrogate these assets individually, or dynamically search and edit those assets in device admin, and visualize how those assets communicate based on real-time data flow using the Explore feature.